Hello everyone, and welcome to another SOLIDWORKS Tech Tip from Hawkridge Systems. This is Jacob Ames, Senior Applications Engineer, and in this video we're going to be discussing a subject that's very popular not only within the SOLIDWORKS community, but throughout the design community as a whole, and that's how to work with imported models. Now this can be challenging for many SOLIDWORKS users who collaborate with other departments or vendors that use different design programs, because imported files don't contain any of the parametric features in the design tree like a regular SOLIDWORKS file would. This means there's no way to simply change dimensions or edit the existing geometry of an imported part, unless you keep watching, that is. The term direct editing is used in SOLIDWORKS to describe the process of making changes to a design by modifying the geometry directly through moving faces, splitting solid bodies, and a number of other techniques as opposed to editing existing features. In this video, we'll be covering some of the most popular direct editing tools and workflows to get you up and running with your imported models. First things first though, we need to import a model. Here I have a step file of a door handle, but if you're not using step format, don't worry. These techniques apply to IGES, Parasolid, Inventor, Creo, and most other imported models, and most techniques apply to both solid and surface models. Finally, there is one big exception. If you work primarily with STL or other mesh file types, most of these tools will be unavailable, but don't worry. We've got a video just for you, which I've linked in the description below. Alright, let's get back to it. First, it's always good practice to run import diagnostics on any imported model. Hopefully, the Import Diagnostic Property Manager won't report any bad faces or edges, but if it does, you can use the tools here to heal any broken edges or faces. Additionally, imported models usually come in using the shaded display style. If you like this, feel free to keep it this way, but I'm going to switch to shaded with edges mode so that I can see all of my tangent edges. At this point, we're ready to investigate some direct editing tools. This set of tools is so popular it even comes with its own dedicated Command Manager tab. To show it, simply right-click an existing tab, use the tab's flyout, and choose Direct Editing. In this tab, you'll find a collection of the most common direct editing commands, and we're going to start with the very first, Move Face. Move Face features three modes: Offset, Translate, and Rotate. The simplest mode is Translate, which allows you to move faces using a specified direction and distance, and then extends any adjacent faces to fill in the gap. In this case, I'm selecting all of the faces of the handle except for the cylindrical portion, which will be doing the extending. You can use the selection toolbar here to automatically select multiple faces at the same time. You'll need to be careful and make sure to include fillets and chamfers if applicable, as faces with adjacent fillets typically can't be translated on their own. In the parameters section below the selection window, you can change the end condition if applicable, and optionally add a direction reference for the move if the X, Y, and Z directions of the triad aren't suitable. Finally, specify the distance you'd like to move the faces, and just like that, the cylinder is extended, all without the need for pre-existing features. For any direct editing feature that includes a distance or angular value, an associated dimension will become available and may be adjusted just like any traditional SOLIDWORKS feature. The rotate option of the move face command is very similar, except that you'll need some sort of rotation reference. This can be an axis, a sketch line segment, or a linear edge. In this case, I'm using a temporary axis through the center of the handle, inputting a value of 45 degrees, and calling it a day. It doesn't get much easier than that. Finally, the offset mode allows you to extend or compress faces by offsetting them in the direction normal to the faces at each location, and then extending adjacent faces to fill in the gap. This is especially helpful for resizing cylindrical faces like I'm attempting to do here. Simply select the applicable faces and specify an offset distance. The direction is taken care of automatically. However, in this case, you'll notice that simply offsetting the cylinder faces isn't quite working. For all modes of the Move Face command, adjacent fillets and chamfers typically need to be selected as well, or the feature will fail as the fillets try to extend to fill in the gap. But in this case, even once I include the fillet faces in the offset, I seem to get some strange results. Remember, offset mode does in fact offset all of the included faces by the specified distance, so the fillets are increasing in size as well. So then, what to do? We'll come back to the Move Face command in a moment, but first, we need to talk about the Delete Face command. This tool is used for a number of reasons, including the enhancement of blend quality in surfacing workflows, but in our case, we can use it to remove the fillet geometry that's been hindering our offset Move Face feature. Delete face has a few different options to consider for different circumstances. The first is simply delete, which will remove the selected faces entirely and will also result in a surface model. This is generally used in surfacing workflows, so unless that's part of your plan, don't worry about this mode. The delete and patch option will remove the selected faces but will then automatically extend the surrounding faces to fill in the gap. Similarly, the delete and fill mode will patch the deleted faces but does so by patching edge to edge rather than by extending the adjacent faces. There's also a tangent fill option for delete and fill for a smoother result. In our case, we need to get rid of the fillet face that's stopping us from using the move face command. To facilitate this, I'll use delete in patch. That way I'll have a nice edge ready for a fillet. And that's all there is to it. Now, going back to the move face command and using offset mode once again, I can easily increase the size of the cover portion of the handle. Then I can follow that up with a fillet feature to replace the one that I deleted, and it's like it never even happened. Plus, I can make any future fillet adjustments parametrically, and I can always edit the delete face feature to remove more fillet or chamfer faces if required. So far we've seen the move and delete face commands, but what about the rest of these direct editing tools? The remaining commands, other than the chamfer, fillet, and pattern features, all deal with multi-body parts. If your imported model contains multiple bodies, they can be moved, deleted, and used in a number of other different ways. Let's suppose I wanted to reorient the handle portion of this design so that it's mirrored to the opposite side and then rotated 90 degrees around the x-axis. Where do I start? Well, first, let's take a look at the split command. This tool allows you to split a single body into multiple pieces by using a plane, a surface, or even a sketched line as a cutting tool. The split command doesn't actually remove any geometry like a cut would, but instead it separates the bodies along the profile of the splitting tool. Once the splitting tool is ready, simply start up the split command, select the tool, and click Cut Part. This will automatically separate the part into potentially several bodies, 3 in our case. Then we need to select the bodies we wish to actually separate. You don't have to include everything here. We're only going to select the cylindrical portion, otherwise the handle will be split into 2 as well. Before clicking OK, you'll want to make sure that the Consume Cut Bodies option is disabled, or the body will be deleted after the split. Finally, click OK to see the results. It doesn't look like much has changed, but the part is now 2 separate bodies, which is just what we need for our next command, Move Copy Body. This command does exactly what you think it does, but there's a couple different ways to use it. When you start the command, you'll see one of 2 interfaces, which can be toggled at the bottom of the property manager by clicking either Constraints or Translate/Rotate, whichever one shows up. In the Constraints mode, bodies are moved through the equivalent of assembly mates. This can be very helpful when measurements are unknown or when geometric relationships take priority over dimensions. Multiple mates can be added at once by selecting the mating geometry, choosing the proper mate type and flipping the alignment if necessary, and then using the Add button. Once all the required mates have been added, click OK and the body will remain in its new position. If you're a little rusty with mates, don't worry. You can find an overview video of assembly mates and degrees of freedom linked in the description of this video. In this example, I've added a coincident mate between the face I'd like to be the new front of the handle and the flat piece of the cylinder. In Translate/Rotate mode, simply click the body you'd like to move and use the on-screen triad to drag or rotate the body. For more precision and control, you can always modify the values in the field for delta XYZ if translating, or the values for rotation, origin, and angle if you're rotating. Additionally, you can choose a direction reference like a linear edge or vertex to constrain the movement if desired, and the copy checkbox will control whether a duplicate body is added or not. It should be noted that translate and rotate movements cannot be combined in the same move copy body command, so multiple features may be required. And additionally, you can use the copy option of this command without specifying any translation or rotation to get a perfect duplicate in the same position of your original body. Now here I've added a rotation operation to rotate the handle 180 degrees and then a translate operation to finalize the position. At this point, my model's looking good, but it's still 2 separate bodies. So how do we combine them? With the combine command, of course. Combine is commonly known as Boolean in other CAD programs and can be used to add, subtract, or keep only the intersecting volume between two bodies or multiple bodies. To turn our door handle back into one body, I'll simply select both bodies using the Add mode and click OK. Piece of cake. Now I can add in the fillets I deleted earlier to make the split easier. Our imported model also has a few extra bodies that have been hiding until now. This body represents the space that the inside lock components will occupy, and as such it needs to be removed from the model. This is a simple task for the subtract mode in the combine command. The handle represents the main body, while the second piece represents the portion that I'd like to subtract. Any bodies used for subtraction will automatically be deleted from the model, leaving the internal details visible in this case. Our last direct editing command is delete keep body, which is particularly helpful if you like to use tool bodies for creating features, as is common with the indent command. In this example, I have a couple fastener parts that have been included as separate bodies. The indent command allows me to use this body to create a cut in the door handle in the shape that I need, and this is similar to subtract. However, unlike subtract, it leaves the body behind, which can sometimes be useful for later reuse, but in this case is unnecessary. Using delete keep body, I can select what I want to keep or what I'd like to get rid of, safely deleting bodies as needed. Now, there are many other commands that could be considered direct editing tools in some capacity, such as the indent command mentioned a moment ago, along with intersect, deform, and a number of others. And if you'd like to learn more about those commands, make sure to check out our other videos that cover them in detail. For now, I hope that this video has given you a better understanding of some key direct editing tools and workflows so you can get back to work on your imported models. And before we go, I'd like to leave you with this summary of the tools that we've covered today. If you enjoyed this video, please give it a like and consider subscribing to the channel if you haven't already. We've got a library of hundreds of SOLIDWORKS videos like this one waiting for you, and we feature new SOLIDWORKS tech tips every week. Finally, if you'd like more information on our products or our SOLIDWORKS training opportunities, visit our website at hawkridgesys.com. Thanks for watching, and see you next time.